Welcome to this video tutorial on the dashboard tool developed by MUNICIPIA for the URBREATH project. In this tutorial, we will guide you through the main features of the dashboards built using Apache Superset, showing how environmental and air quality data are visualized and analyzed. You will learn how dashboards are structured, how charts are created from datasets, and how different visual elements can be combined to provide clear and effective insights into urban environmental conditions. This tool is designed to support data-driven decision-making by enabling users to explore measurements, compare trends over time, and better understand the impact of environmental parameters across different cities. Let's get started and discover how the URBREATH dashboards can help transform data into actionable knowledge. So let's see how users can access the dashboards that have been created for the project. There are two types of users available: a public user who can view the dashboards in read-only mode, and an administrator user. The dashboards for guest users are available on the URBREATH UI website in the KPI Analytics Level View section. In this section, the cities for which dashboards are available are listed. These dashboards are based on data collected through sensors, and a dedicated dashboard has been created for each city. Let's see the example of Cluj-Napoca. Here, the guest user can access the dashboard, read the dashboard explanations, and view the geolocation of the sensors. In this case, the sensors measure data related to environmental pollution, which are shown in the dedicated section. The user can also view the predefined charts and, where available, apply filters to the charts. This allows the user to filter the selected time period. The dashboards are organized into sections related to specific topics. Currently, the dashboards are populated with environmental pollution data and climate data. For example, for Cluj-Napoca, there are also dashboards dedicated to historical temperature and precipitation measurements. In this case as well, the user can apply filters. In this example, the chart allows us to visualize the months in which the temperature was greater than or equal to 9.34 degrees, and it graphically highlights phenomena that may be related to climate change, both in terms of warming trends and overall temperature increases. Here we can view the reference sensors used for climate measurements, namely the observatories, and we can also identify the months with the highest levels of precipitation. In this case, by filtering the individual values, it is possible to determine which months recorded the highest precipitation over the years. Let's move on with the administrator uses Apache Superset to explore data, create charts, and build interactive dashboards. Step by step, we will move from dataset exploration to chart configuration, and finally to dashboard creation and customization. The administrator logs into the application through the Superset login URL. After accessing the platform with administrator credentials, the user can manage several sections of the system. These include the dashboard, charts, and dataset sections. In Superset, the fundamental building block for creating a dashboard is the dataset. A dataset represents a view on the data and can be created by querying one or more databases, depending on the use case. In this example, we explore a dataset in order to build a chart that will be added to a dashboard. We start from the Bright General Measurement dataset, which contains several data columns. First, we select the type of chart we want to create, for example, a line chart. On the x-axis, we choose the time dimension, which corresponds to the measurement date. We then build a chart that allows us to visualize the annual average of a selected parameter. The reference metric is the average sensor measurement using a mean aggregation. The reference dimension is the sensor. At this point, we need to apply a filter to select the city for which we want to generate the chart. The available cities are Cluj-Napoca, Leuven, Madrid, and Tallinn. We select the desired city. Next, we choose the parameter to analyze. In this case, we select NO2, which is part of the environmental pollution data. By clicking the Run Chart button, we can preview the chart. The chart shows the yearly average trend of NO2 concentrations, measured in micrograms per cubic meter. We can now save the chart by assigning it a title. Once saved, the chart is added to the list of available charts in the Charts section. The user can reopen the chart at any time to make further changes, such as customizing the title, adjusting the X-axis label, or adding a Y-axis title. After making changes, clicking Update Chart will apply them. The user can now edit an existing dashboard or create a new one. To modify an existing dashboard, the user clicks the Edit button. Layout elements such as rows and columns can be added, and the chart can be placed inside a column. The chart can be resized and accompanied by text elements to help explain the data being displayed. By clicking Save, the dashboard is updated. Alternatively, the user can create a new dashboard and reuse the existing charts. In this example, we create a new dashboard, assign a title, and define the layout using rows and columns. We can add multiple charts even if they are based on different measurements. For instance, we add a map showing the location of sensors in the city of Leuven, along with other informative elements. Finally, we add a descriptive title and save the dashboard.